So let's try to understand some rational exponents. All right, so this is just an example of what a rational exponent looks like. It's a fraction, okay? And so you need to really have a good understanding of your rules of exponents in order to be able to do this section, all right? So whenever you have a power raised to a power, what do you do with those powers? You multiply them together, right? So really we have 8 to the 3p power is equal to 8. Well, what is the exponent up here? It's a 1. We don't usually write it, but it is there, okay? So if your bases are the same, and we know that these are equal to each other, doesn't that mean that our exponents must be equal to each other? For sure. So we know that 3p is equal to 1, and then to get p by itself, to solve for p, you would divide by 3. So p is equal to 1/3. All right, so that's how you solve for a variable that's in the exponent. All right, so this is a rational exponent. All right, so here's your definition right here. So it says that your index is going to be the denominator. All right, and just so you know, the denominator, it says here that it needs to be greater than or equal to 2. All right, so if you have a base that's raised to a fractional power, you can change it into a radical with an index that is the denominator. The base goes under the radicand. All right, we'll talk about what happens if that's not a 1 later. All right, so let's just get some practice writing these from rational expressions to radical expressions, okay? All right, so we've got x to the 1/2 power. We could write that as the square root of x. And remember, there is a 2 up here. We don't usually write it. It's understood to be there, okay? All right, let's look at part B. All right, so y to the 1/3 power is the same thing as the cube root of y. Z to the 1/4 power is the same thing as the 4th root of z. So you should practice going back and forth between the two. All right, so now let's practice going the other way. So remember, this is a 2 up here, and so this would be, on part A, that would be x to the 1/2 power. On part B, let's look at that. It's got a 3 in the index, so this would be y to the 1/3 power. And then let's look at C. This would be z to the 1/4 power. All right, so for this one, they want us to write this as a rational exponent, which means a fractional exponent, okay? So on A, we've got the square root of 5y. This can be written like this. Don't forget, you have to have the parentheses here. Okay, so that's part A. Part B is, let's see here, the cube root of 4x. You do need a set of parentheses here, so we'll put 4x inside the parenthesis, and now we have 1/3 as the exponent. All right, let's look at C. So on C, we have, there's a 3 out front. Don't forget that 3, okay? But the only thing that's going to go inside the parentheses is the 5z. So we've got 3 out front, then we have parentheses, 5z goes inside the parentheses, and then 1/4 goes outside the parentheses in the exponent. All right, so now let's go ahead and simplify this. 25 to the 1/2 power means the square root of 25, which is 5. All right, let's look at B. 64 to the 1/3 power is the same thing as the cube root of 64. So what times itself 3 times gives you 64? Well, that would be 4. All right, let's look at C. So we've got 256 to the 1/4 power, which means the 4th root of 256, which is the same thing as what times itself 4 times gives you 256? That is also 4. Okay, so for this one, let's look at A. We've got, let's go ahead and write it as a radical. So we've got the cube root of negative 64. Now that says what times itself 3 times gives us negative 64. And since we have a 3 up here, it is a real number, okay? So that would be negative 4. All right, let's look at B. So we've got negative 64 to the 1/3. So the negative is going to be outside. Then we've got the 3 in the radical, as the index, and then 64 inside the radical. And so you're taking the cube root of 64, not negative 64 this time, just positive 64. So that would be a positive 4, but you've got this negative out front, so this answer is also negative 4. All right, let's look at C now. Notice that the negative sign is in the exponent this time. So that means that we have actually 1 over the cube root of 64. That does not mean that our answer will be negative, okay? It just means that it doesn't like its location. So we already know that the cube root of 64 is 4, so this answer would be 1 over 4. All right, let's look at A. So we've got negative under the radical. We've got a negative 16. Our root is a 4, or our index is a 4. Okay, so we're taking the 4th root of negative 16. Now remember, when this is even, there is no such number that can multiply times itself 4 times to give you a negative. So this answer would be no real number. You could say no real solution. All right, on B, notice that the negative is not in a parenthesis this time, so that means it's going to sit out front, and we want the 4th root of 16. But we want the negative of that, okay? So this would be negative 2. All right, let's look at C. So notice that the negative sign is up in the exponent this time. So this would be 1 over the 4th root of 16. And so that would be 1 over 2. Okay, so this page is showing you what happens when your numerator isn't 1 anymore, okay? So you still put the denominator in the index place, okay? You still put the base under the radical. But this is showing you have options here. You can either put the m outside of the parentheses, or you could put the m under the radical. So you have options, and you might be asking yourself, well, how do I know which one? Once you do enough of these problems, you'll see where the tricks are, and you'll know that it doesn't help me. This won't help me if I put it under the radical, so I must go on the outside, okay? So let's just take a look at some examples and we'll talk about it. First, let's just start by writing these as rational exponents, okay? So on part A, we have the square root of y to the 3rd. So that can be written as y to the 3 over 2. That's another way to write that, okay? All right, let's look at B. So we've got the cube root of x squared. That can be written as x to the 2 over 3. All right, let's look at C. the fourth root of z cubed can be written as z to the 3 over 4 power. Okay, so now let's calculate some of these. So we have 9 to the 3/2 power. That means that we have the square root of 9, which we can easily take the square root of, so let's not put that 3 under the radical. Let's put it outside. And so we can easily take the square root of 9, which is 3, and we're going to raise that to the 3rd power, which is 27. All right, let's look at B. We have 125, and that goes under the radical. The 3 will go up in the index place. And let's look at the 2. Let's put the 2 on the outside, okay? Because we can take the cube root of 125 pretty easily. It's 5. So then we have 5 squared, which is 25. All right, so let's take a look at C. So we've got the fourth root of 81, and I can easily take the fourth root of 81, so I'm going to put the 3 outside and raise it to that power out there, okay? So that would be, fourth root of 81 is 3. 3 to the 3rd power is 27. All right, so let's look at A. So notice that the negative is in the exponent. That means it doesn't like its location. It's going to move location, so we'll have 1 over the square root of 16, but we also need to raise that to the 3rd power. Okay? We took care of the negative in the exponent. We moved everything to the denominator. We've got the 3 accounted for right there. The 2 is accounted for right up here in the index. We don't usually write it, but it is there. Now, I can take the square root of 16, which is 4. So this would be 1 over 4 to the 3rd power, which would be 1 over 64. All right, let's look at B. So we've got, again, the negative means that it doesn't like its location, so it's going to be 1 over. We want the 5th root of 32, and then we want that answer raised to the 2nd power. So the 5th root of 32 is 2. So I've got 1 over 2, but that's going to be squared, so that means I have 1 over 4. All right, let's take a look at C. So again, the negative is in the exponent, which means it doesn't like its location, so this would be 1 over, and I've got the square root of 4, but I want to raise that to the 5th power, okay? So this would be 1 over 2 to the 5th power, which is 1 over 32. All right, so let's look at part A on this one. Let's see here. There is no parenthesis around this, so the negative is just going to sit out front. And I've got, let's see here, the square root of 25, but I want to raise that answer to the 3rd power. Notice the 3 is right here. The 2, it's not written, but it is understood to be there. The negative sign is out front. The 25 is under the radical, okay? So now, let's take the square root of 25, which is 5, and raise that to the 3rd power. 5 to the 3rd power is 125. Once you get that answer, multiply it times that negative. So this answer is negative 125. Okay, so how is this one different from that one? The only difference is they both have the negative out front. They both have the 25. The only difference is the negative in the exponent, okay? So it's really done the exact same way. The only difference is it'll be a fraction answer. So it would be negative 1 over 125 as our final answer here. All right, let's look at part C. So notice the negative sign is inside the parentheses. that means that it's going to be under the radical. So I want to take the square root of negative 25 and take that answer and raise it to the third power. Okay, the 3 is right there. The 2 is in the index. We don't write it. It is there. The negative, because it's inside the parenthesis, goes under the radical. But now think about this. Can I take the square root of a negative number? I sure cannot. Okay, so this would be no real solution. Or you could say not a real number. All right, this page is just reminding you of the rules of exponents that you've already learned. You learned it back in the 90 class. And so if you don't have these somewhere in your notes, you probably should write these down and have them in your notes and keep them handy on tests and quizzes and things like that. All right, so let's use those rules of exponents and let's solve some of these. All right, so on part A, notice we have the same base and we're multiplying. So whenever you have the same base and you're multiplying, you add your exponents together. So we would have 1/2 plus 5/2, which gives us 6/2. And whenever you simplify that, you get 3. So this is really 2 to the third power, which is 8. All right, let's look at B. So on B, we have the same situation going on. So we're going to add 2/3 plus 4/3, and we get 6/3, which is 2. So this is really x squared, and there's nothing else we can do to that. All right, so let's take a look at C. Same situation going on. So we're going to add 3/4 plus 5/4, and we get 8/4, which is 2. And so you have z squared on this one as well. All right, so according to the rules of exponents, whenever you have a power raised to a power, you multiply your powers together, okay? So we would have 4 times 1/2, which is 2. So we would have x squared on part A. On part B, we have 6 times 1/3, which is the same thing as 6 divided by 3, which is 2. So we would have y squared on this one. And then on part C, we have 9 times 2/3, which that goes in there once, that goes in there 3 times. 3 times 2 is 6, so we would have z to the 6th power. Okay, remember the rule for if you're dividing. If you're dividing and you have the same bases, then you subtract. So this would be 4/3 minus 1/3, which is, 3/3, which is 1. So this would be just plain old x on part A. On part B, you would have, let's see here. Again, you're dividing and you have the same base. So you've got 3/4 minus 1/4, which gives us 2/4, which is 1/2. So you've got y to the 1/2 power. You could either leave it like that or you could say the square root of y. All right, let's look at C. So we have z to the 2/3 divided by z to the 5/3. So we would have 2/3 minus 5/3, which is, what is that? 2 minus 5, that's -3/3, which is -1. So we would have z to the -1 power. Don't give me answers with negative exponents unless we're dealing with scientific notation. So you need to simplify that and make that 1/z. All right, so the rule says if we have something inside parentheses and we're raising it to a power, we take each piece and raise each factor and raise it to that power, okay? And then whenever you have a power to a power, you have to multiply those powers together. So this would be 27 to the 2/3. That looks terrible. Hold on. Sorry. On part A, we would have 27 to the 2/3 power, and then we would have u to the, whenever we multiply those together, we get 2/6, which is 1/3, okay? So I'm going to change that to 1/3. Okay, So now let's see about simplifying this right here. So we would have the cube root of 27, and that answer is going to be squared, times, and you could either leave this as u to the 1/3 power, or you could change that to the cube root of u. It's up to you. All right, so what is the cube root of 27? That's 3, and then 3 squared is 9. So we would have 9u to the 1/3 power. All right, so let's look at B. All right, so we would have, let's see here, 8 to the 2/3 power, and then we would have v to the power raised to a power we're going to multiply. So I would have 2 over 12, which is 1/6. Okay, 2 over 12 is 1/6. All right, so now let's do this. Let's do the cube root of 8, and we're going to square that, and then v to the 1/6 power. Now, the cube root of 8 is 2, and then 2 squared is 4. And there we go. We're done. All right, let's look at part A on this one. So we've got m to the 3rd to the 1/3, so that would be m to the 3rd times 1/3, and then we've got n to the 9th times 1/3, okay? So that would give us m to the 1st power, don't need to put that 1, it's understood to be there, n to the 3rd, and that's it. All right, let's look at part B. So I've got p to the 4th power times 1/4, and then I've got q to the 8th times 1/4. And so that's the same thing as p to the 1st power q squared. Last couple of examples, but these look like hot messes. Look at this. Okay, so whenever we have like bases, let's simplify the numerator first, and then we'll worry about the denominator, okay? So whenever you have the same base, you add your exponents together. So I'm going to add, let's see here, 3/4 plus -1/4. And that gives me 2/4, which is 1/2. So in my numerator, I actually have x to the 1/2 power, and in my denominator, I've got x to the negative, I'm going to go ahead and simplify that, 3 over 2 power, okay? Now, remember that we are allowed to subtract whenever we have the same base and we're dividing, okay? So we would have x to the 1/2 minus -3/2. Don't forget, you have a double negative here, okay? So let's do change. And then we have, let's see here, x to the 4 over 2, which is x squared. Okay, if you're still writing, then you might want to hit pause because I'm going to erase this so that I have room to work problem B here. So hit pause if you're still writing. All right, so on part B, it's done the very same way. So we would have 4/3 plus, remember this is a 1 right here, but I want to write it in terms of a denominator of 3. So actually, I would write this as 3 over 3. Because remember, 3 over 3 is 1, okay? So I'm going to add 4/3 plus 3/3, which gives me 7/3. So my numerator is actually y to the 7/3. My denominator is y to the -2/3. Okay, so remember, I'm going to subtract here. So I've got 7/3 minus -2/3. Change. And so that gives me 9/3, which gives me 3. So I end up with y to the 3rd power. All right, that's it for this video. If you have any questions, don't hesitate to reach out to me, and have a wonderful day.